So, hey, hello. Let's see here. Starlet the Hollywood, how you doing today? I know I be messing up y'all's names. It is not on purpose, y'all, for real. It's not on purpose. Hello, Nadia on social media. How are you today? All right. So I hope you guys are doing well today. Matter of fact, as I mentioned before, we're going to be I got you. You know what? Everybody got a burner account, right? Because sometimes we be trying to hide from our employers, or you just hiding from people that you don't want to be bothered with. You don't want everybody to know what you're doing, and that's fine. I don't mind that at all. Have a private life. Everybody needs a burner account every now and then, right? Yes. Hey, Millie. Hey, Connor. Yes. So I hope you guys are doing well today. It is Thursday. I've heard some people refer to this as Baby Thursday or Baby Friday. I don't know what that's supposed to mean, but I guess because it's one day closer to the weekend, for those of you all that may get off on Fridays. So what we're going to do today is go through the gas laws, and I'm going to do a lot of math problems so that you guys can see that. Thank you, Zaneb, for that. Thank you. And so we're going to go through different types of gas law problems. We've been talking about Boyle's law, Charles' law, Gay-Lussac's law, and today we're going to actually go through what's called the ideal gas law, and also we dealt with Avogadro's gas law yesterday as well. But we're going to go through the ideal gas law today, as well as the molar volume gas law. If we have time, we will deal with Dalton's law of partial pressure, if we have time, okay? I go live Monday through Thursday, 12 noon Eastern Standard Time, and I go live during that time because I consider this like lunchtime chemistry. So for those of you guys that are getting ready for your test, this is like the time to do it. And so what we're going to do is consider the processes of these problems, these word problems, and I'm going to explain to you guys how they all work so that you're able to, do well on your next test. Okay. Now, for those of you that are in chemistry, you may be doing these types of problems. And a lot of times when you're working with word problems, it's hard to understand what they're asking you to do. But the thing is, you've got to look at what they want you to do and then kind of go from there. So for instance, if we look at these first set of problems here, okay, it says you're going to use molar volume to find volume at STP. So that's standard temperature and pressure, okay? Standard temperature and pressure. So let me go ahead and kind of explain the background of what you guys are going to be doing today with me, okay? So it says, if they give you, it says, what is the volume in liters of 6.40 grams of oxygen gas at STP? One thing you have to consider is that when you hear the word molar volume, molar gas, you have to think of this phrase here and STP. You have to kind of think of it this way. Okay, so let me go ahead and share with you all a couple of things. 1 mole, okay, of whatever gas you're dealing with is going to equal to 22.4 liters of said gas. Okay, so the thing that you want to recall with this is that when you say moles, that means you need to convert the grams if they did not give it to you in that way already. So a lot of times in chemistry, you have multiple steps that you have to actually go through in order to solve the problem. So I'm going to do that with you all right now. Okay, so here you've got 6.40 grams of oxygen at STP. What you'll need to do, of course, with this particular problem is to convert, or first you need to find out the molar mass, okay? So let me put that here as the first step. Find the molar mass, okay, of O2. Now, of course, we know that O2, okay, there are two of them, and the molecular weight on the periodic table for oxygen is 16. So we're going to say 2 times 16.00, okay? That's equal to 32.00 grams per mole. Now, this is going to play a role in something else that we're going to do after we go through this particular problem, okay? So keep that in mind. Keep that in mind. What you'll need to do after we found the molar mass of oxygen and we get 32.00 grams per mole, we're going to take that 6.40 grams and convert it to a mole, okay? Yes. So in step number 2, okay, we're going to take that 6.40 grams of oxygen and we're going to convert that to a mole. So 1 mole, okay, of O2 equals the 32.00 grams of O2. Of course, we're going to cancel out the grams because we don't need that. We were looking for the moles. Now, what you do need, of course, is your calculator to calculate this with me online, okay? So I've got, whoops. I'm going to plug in on my calculator, okay? 6.4 divided by 32.00. So that gives me 0.2. Okay, thank you, the Wild Rob. Very good. 0.2. Okay, now because we're dealing with sig figs, you know, in chemistry, you know how that thing works with the significant digits. You're going to put 3 of them. Okay, so that's 0.200. Your calculator doesn't know to give all those significant digits, but you got to include them when it comes to this particular part of the lesson. Because a lot of times when you guys are doing homework on, let's say, Mastering Chemistry, that's the software that we use at my school. And if you don't include the correct number of significant digits, you'll get the answer wrong. And you're going to try to figure out, well, what did I do wrong? And it was something dealing with your sig figs. Just a little FYI. Now, we're going to take that 0.22, okay, I'm sorry, 0.200, okay, in this third step. And we're going to say the moles of oxygen times, remember, they want you to find the volume. So on the very top, we're going to go back here to this whole process of 1 mole of the gas being equal to that number, that 22.4 liters at STP. So what I'm going to put on the top is that 22.4 liters of oxygen, and on the very bottom, 1 mole of that gas. Cross out your moles, okay? And so now all you got to do is multiply that 0.2000 times the 22.4, and you get 4.48 liters. Thank you, the Wild Rob. So 4.48 liters of O2, okay? That's it for that particular problem. Now, it appeared as though that was a lot of steps, but it's really not a lot of steps when you consider the fact that they did not give you your moles. Had they been direct and giving you your moles, guess what? Then you can just go straight to step 3 by taking the moles of your gas and multiplying it times 22.4. Okay, that's the one thing I can say. As most chemistry teachers, what we will do is make you go through a lot of steps. Now, it's not to make you feel stressed, no, but we want to make sure that you're able to comprehend the steps that you need to go through in solving these problems. The easiest thing would have been to have already had this number of 6.40 grams in a mole, therefore skipping steps 1 and 2. Now, you may get a problem like that where all you have to do is just simply multiply it times the 22.4. But if you're not given a straightforward problem like that, then go through these steps right here, okay? Now, let's go ahead and get to the next problem, okay? The next one deals with helium. So, same type of problem, okay? Only difference is it's a different gas. So right here, it says, what is the volume in liters of 5.10 grams of helium at STP? So again, we're going to do like we did before, and we're going to simply convert the 5.10 grams of helium, okay, to a mole. So 1 mole of helium is equal to the molar mass on the periodic table. And I know that the weight for helium is 4.003, okay, grams. So now what you're going to do, you can actually take this in one long swoop, and this is what I mean by that. Get rid of your grams, yes. And what you can do now in this second step over here is you can go ahead and put on the very top 22.4 liters of helium over 1 mole of helium, okay? And again, get rid of your moles of helium, and now you're left with your liters and what you were looking for initially, okay? So you can do this all in one step, or you can break it apart like I did up here, okay? So you have a choice of how you would want to proceed with this problem to make it easier for you. I always give my students options so they'll know that they can take the route they prefer. Like driving, I can either take the highway or the scenic route, but I prefer to get to it the shortcut way, okay? 5.10, so I'm just going to multiply everything across, times 22.4, and then divide that by 4.003, and I get 28.5. I only need 3 of those numbers. So 28.5 liters of helium is your answer. Okay, 28.5 liters. Any questions from anyone about what we're doing? Okay, why 22.4? Okay, the 22.4 is the number or value given at STP. That is a standard number when we're talking about volume and we're trying to calculate the volume of gases. We know that 1 mole of whatever gas you're dealing with is equal to 22.4 liters at standard temperature and pressure. So that is a given number. Just like if I were to say, what is the molar mass for helium, you would look on your periodic table and find that value. So those are given values for different problems that you do. Yes. Okay. No problem. No problem. Also, I'm glad you asked that question because there are numbers that are standard constants that you have to use, particularly with the ideal gas law, that you have to look on a chart to get the value for it. And those numbers do not change. So it's like you have to use certain formulas and numbers within the formula in order to calculate the answer. It's all good, Elmer. It's all good. You thought Cal 2 was easier? I don't know about that. Coming from a chemist, let me tell you, calculus and I, we had a love-hate relationship too. But you know what? For those of you that can do it, more power to you. You know, and I'm not going to even hate on calculus because you know what? At the end of the day, just as there are chemists, there are also mathematicians. No, I don't do organic chemistry, unfortunately. I get that request a lot. Sue, if you want these problems as a document, like there are tons of practice problems online that you could actually just Google. As a teacher, you know, we have access to a whole wealth of problems, you know, that we actually pull from. And if you have like chemistry books, you know, you can even go to the library and just borrow a chemistry book and practice. But yes, you know, and that's something else that I am working on as well, because so many students have asked me that too, you know, in terms of study guides. And I'm working on study guides that are related more so to what students can relate to. Like a lot of times when you're taking chemistry, you can't relate to the chemistry problems because it's like, okay, what am I learning this for? But I have problems that I make relative to like real life applications. Now, you remember how I said everything that you do will come back later, right? That's because, for instance, in this, yes, the wild rock, that is correct. That is correct. When you have problems like this, remember, density is something that we learned about when in General Chem 1, like at the very beginning of the semester. And if you don't remember the formula for density, it's mass over volume. Well, now you've got to use that same formula similarly for gases, but it's a little different because they're telling you at STP. So what do you have to do? Well, let me show you. You're going to have to use this same type of formula, but instead of saying mass over volume, okay, we're going to actually say molar mass over molar volume. And the molar volume, of course, is that 22.4 liters, okay, that we will be using for this particular problem. So again, I'm going to break this problem down for you guys so you'll know exactly what to do, okay? So because they told you that you were working with nitrogen gas, and that's N2, if your teachers did not tell you the formula, if they didn't write it in like how I did in parentheses, if you just used one nitrogen and thought that that was going to get you the answer, you would get it wrong. And guess what? Your teachers will have a multiple choice answer where you only used, and when you said nitrogen, you only used one N. You've got to use nitrogen as N2, because remember, nitrogen is one of those diatomic molecules that when we say the name nitrogen is written as with the 2 as a subscript. Same thing for oxygen, fluorine, chlorine, okay? Hydrogen, just as an example. So in this case, we need to find the molar mass, okay, of nitrogen. So we're going to say 2 times the weight for one nitrogen is 14.01. So I'm going to multiply the 2 of them times that 14.01, and that's going to give me 28.02 grams per mole. Okay, here's the deal. I'm going to now use that formula up here, the density formula, okay? The part that says molar mass over molar volume. And guess what we're going to do? We're going to plug that in and say D equals 28.02 grams per mole divided by, and remember, the molar volume, okay? The molar, let me put that here so you all will know. The molar volume is 22.4 liters per mole, okay? So let me scoot this down a little bit because it's a little up high, because I want you all to see that these are the things that are given in the problem, okay? And now what you're going to do, you're going to say, all right, well, D equals, remember the molar mass. Let me write that out in case some of you all are like, what? Molar mass over molar volume. That is a difference from just saying mass per volume. Molar mass, that's this number here, the 28.02 grams per mole. I emphasize putting those units so you will know which units cancel out, okay? On the very bottom, the molar volume is this number right here, the 22.4 liters per mole. Now, you guys already know what to do, right? You're going to cancel out your moles because we don't need those anymore. And now we're just going to plug those 2 into the calculator to see what we get, okay? So when I plug this in, the 28.02 divided by 22.4, we get 1.25, okay? You only need 3 of those numbers. 1.25 grams per mole. That is the density of that nitrogen gas, okay? That is the density of that nitrogen gas. It's that simple, guys. I promise you, it is that simple. So let's do another one, okay? Let's do another one. Right here, and again, let me make it a little bit bigger so you guys can see it, okay? Because I know sometimes when I expand the screen, it doesn't always do what it needs to do, okay? So that is the problem right there. And they want to know what is the density of hydrogen gas at STP. Again, if I did not give you the formula and say H2, if you just put hydrogen, there is an answer dedicated to you on your test for getting it wrong in that manner, okay? So in this particular case, because I'm trying to find the density, remember, D equals the molar mass. And some of you all may think this is being redundant writing the formula out, but I promise you, if you write it out each and every time, it becomes second nature. You need to find the molar mass, okay, for hydrogen. Remember, I have 2 of those times the molar mass weight on the periodic table, which is 1.008. So I'm going to get 2 times 1.008, and that gives me 2.016 grams per mole. Okay. Now, all you need to do, again, use the molar volume, which is 22.4 liters per mole. Okay, remember we talked about that before as well. Okay. And so now all you're going to do, you're going to use both of those values here, the 22.4 liters per mole and the 2.016 grams per mole. Okay, so we're going to plug those in and we're going to say, all right, well, D equals the molar mass, which was the 2.016 grams per mole, divided by 22.4 liters per mole. Because remember, the density values, or units rather, are grams per liters, milligrams per cubic meters. It could be centigrams per liter, per milliliter. It's whatever the mass unit you have per volume unit that you're working with, okay? Cancel out your moles because we don't need them anymore. And all you need to do now is plug in those numbers. 2.016 divided by 22.4, and you get 0.09. 0.090, okay, because we need 3 significant digits, 0 grams per liter. Okay? That's all you have to do. And remember, your teachers may put on your exam to see if you're on the right track. They may say A, 0.09 grams per liter, B, 0.009 grams per liter, or C, 0.0900 grams per liter. And if you don't know the correct sig figs, okay, and here's how you know that. It's the least of your digits. You've got 4 sig figs on the top, 3 on the bottom. Therefore, you need to have 3 significant digits in your final answer. Your calculator is going to give you the one that I'm highlighting in pink. They don't include those zeros because your calculator doesn't know to do sig figs. You have to do it for your calculator. And if you leave off those extra zeros and you choose that as your answer choice, you're going to think, well, why did I get this wrong? I mean, that's what my calculator told me. But again, you have to know in chemistry, we have to go with the correct number of sig figs, okay? That's why. All right, now, here is another type of problem, but this time it's dealing with calculating the molar volume at STP. Okay, let me rephrase the question. Sorry, not calculating the molar volume. They want you to calculate the number of moles, okay, using the molar volume at STP. Okay, they're wanting you to calculate the number of moles for that. So let me show you what we're going to do, okay, to solve this problem. So again, I'm making it a little bit bigger so you all can see it, okay? And here we go. What you guys are going to do is use a different type of formulation for this part, okay? So first thing you're going to need to do, okay, for problems such as this, you're going to take the 44.8 liters, okay, because they did give you that number, 44.8 liters of oxygen times on the very top. If you remember that molar volume format that we used before, we know that 1 mole, okay, of the gas, whatever the gas is equal to 22.4 liters of that gas. And that's what we have right here, okay? You're going to cross out the liters because we don't need that anymore. And if you have the same unit on the top and the bottom, you get rid of them, okay? What you're going to do now is take the 44.8, divide that by 22.4, and you get 2, okay, moles as your answer. But we're going to say 2.00 moles, okay, of oxygen. And guess what? Are we done? Yes, we are. That's it. Okay? That's it. So, because they wanted you to calculate the moles of oxygen in 44.8 liters, all you had to do was just divide those two. Nothing more to that particular type of problem. Okay? So, let me give you all another one right here. And I want you to calculate the volume, okay, of, because I didn't finish writing this one out, 6.40 grams of oxygen, okay, of oxygen gas. All right, so again, if you go back and look at this problem right here, they gave you the liters, right? Okay, they gave you the liters in this problem, and you had to find the moles of that using the molar volume at STP. So in other words, you're going to use the molar volume, which is this number right here, the 22.4 liters per mole of oxygen. You're going to use that in every problem. But here's the deal with this one, though. You see how I gave you just the grams, okay? I gave you grams for this. Well, let me go ahead and make this one a little bit bigger so you all can see it. Okay, remember, if we're asking you about molar volume, mole, think about that key phrase mole, what you're going to have to do is convert the 6.40 grams of oxygen to a mole, okay? So you're going to take that 6.40 grams of oxygen gas and convert that to a mole of O2. That means you need to find the molar mass of oxygen. You have 2 oxygen atoms times the molecular weight of 16.00, and that gives you 32.00 grams per mole. Now, what are you going to do? You're going to say, all right, 6.40 grams of oxygen times. Remember, on the top, we need a mole. On the bottom, we need to get rid of those grams. That's why we're putting 32.00 grams on the bottom. Again, you're going to cancel out your like terms. Grams goes away, not the number itself. And you're going to simply plug that in. 6.40 divided by 32.00, and I get 0.200. Remember, you got to add those zeros, even though your calculator won't do that. Now, that gives me my moles of oxygen. Now, you already know what to do, right? Use a molar volumes value to find the volume of that in liters. So in this step right here, okay, so this was step 1. In step 2, you're going to take that 0.200 moles of oxygen times 22.4 liters of oxygen over 1 mole of oxygen. And all you're going to do, guys, is just cross out your moles of oxygen and put that in your calculator, 0.200 times 22.4, and I get 4.48 liters. And that's the correct number of sig figs, okay, of oxygen gas. Now, these problems here, you've been given several different examples of how to apply different formulas. As a teacher, I would do this. I would even go through a more challenging problem like these, where you have to go the extra mile, meaning extra steps to get to the answer. A lot of your homework will have given you moles, and you just do step 2. Like you wouldn't have to do step 1 because it's already in moles. But if it wasn't done that way, you have to first do the first step, which is to convert your grams of whatever they give you to a mole and then proceed. This is why I tell students all the time, what you learn in the 5th week of the semester comes back in like week 12, week 10, week, various weeks. So you have to remember, yes, but I, again, will say this, and I'll say it again. Make note cards with all of your formulas on them for each chapter so that the only thing you'll have to do is pull the note card out, look at the way it was done in terms of the formula, and then you can work your homework problems. Sometimes when you're going through all of your notes, you get confused as to where the problem was. And unless you're like me, you may also want to use highlighters in your notes. That's why I use different colors also to transition my thought process. When a new step is coming in, I try to use a different color so you guys can see that. Just a little FYI. Okay. Now, I have 20 more minutes left. So what I'm going to do at this time, I'm going to switch gears and we're going to, before we do, let me do one more problem like this, because I want to make sure that you all understand if you're having to calculate the densities of gases in grams per liter, how would you do that? Okay, so that's the other thing I need to show you all also. Okay, so, well, actually, we pretty much did that. Okay, now that I think about it, we actually did that. If you're having to calculate the density, okay, you're doing exactly what we did up here in this step. So if I gave you, let's say CH4, another gas, methane gas, or propane, C3H8, first thing you would have to do again, find the molar mass of your particular compound, and then divide that molar mass by the molar volume of 22.4 liters. Okay, that's it. That is it for those type of examples. Now, let's get to the ideal gas law. How many of you guys are familiar with the ideal gas law? Well, let's talk about that for a moment. I'm going to go ahead and switch my screen over to the new part for those of you guys that are with me on YouTube over here. I just switched my screen over so you guys can see these new problems, okay? Or these new examples. When you're talking about the ideal gas law, it deals with pressure and volume, moles, a gas constant, and temperature, okay? The ideal gas law deals with this following. PV equals nRT. That is the standard formula that you would use for the ideal gas law. Now, here's the thing though, your R constant is typically associated with whatever pressure you're given, okay? So as you guys can see here, let me zoom in so you all can see that. Whatever your gas constant is based on your pressure. Now, here's what teachers will do to challenge you. You may be given the pressure in torr. You don't see a torr up here for either of these gas law constants, do you? No. But what you would do is convert the pressure reading that you're given first in whatever gas law constant you want to use, and then go through the problem, okay? Just a little tip for those of you all that are getting homework problems and the math ain't mathing, as you say, where you're looking at your units and you're like, wait a minute, I don't see the correct pressure reading that I need to use in my gas constant. I can either use ATM or millimeters of mercury. But the thing is, if they give you a totally different pressure unit, you have to convert that pressure unit first to either an ATM or millimeters of mercury, whichever one you want, and then proceed. So now let's do this problem right here. Okay, this gas law constant gas law problem. Now, many of you guys have gone to the dentist, right? I don't like going to the dentist, but I know sometimes they'll give you laughing gas. Well, it didn't do nothing for me. Okay. But an anesthetic used in dentistry, of course, is dinitrogen oxide. Now, again, if your teachers did not give you the formula N2O, you'd be in trouble, okay? Because you would need to know that in order to solve the problem. They want to know what is the pressure in ATM of 0.350 moles of N2O at 22 degrees Celsius in a 5.00 liter container. Now, I've given you a lot of numbers. Well, that's how the ideal gas law tends to work. They give you multiple numbers to fill in. So let's highlight the numbers again so we'll know how to use them. They gave you moles, so you don't have to solve for moles. They gave you the temperature, but we have to put the temperature in Kelvin, so we're going to have to convert that. They give you the volume in liters, okay? We would refer to this chart right here to get our gas constant for the R. And since they gave us they want the pressure in ATM, we're going to use this constant here, 0.0821 liters of atoms per mole Kelvin. And then, again, we're going to flip this formula to solve for P. All right, so how do we do that? Okay, quite simple. Since we're looking for P, okay, we're looking for P, I'm going to say P equals, since N, R, T are together, and they're all on one side, keep them that way, and bring the V onto the bottom. That's it. If I were looking for volume, all you would have to do is, again, keep N, R, T together and put the P on the bottom. Jocelyn, I'm not doing that particular thing right now. I'm sorry. I can't do that one right now. But thank you for your question. Now, what you're going to do, okay, since we're looking for pressure, let's go ahead and write out what we were given, okay? P, N, R, and the T. Okay, I got you. Put that on my last video so I can go back to that one, okay? So that way I won't forget, because honey, out of sight, out of mind. Whenever I go back and look at my videos, they do not play the comments, so I will forget. So type your question back out onto my last video. So you're looking for pressure, okay? You're welcome. You're welcome, Jocelyn. So you were given the moles of 0.350. Okay, so I'm just writing everything out so we will know what we're working with. The R constant is 0.0821. Okay, so you all can see this here. Okay. Liters dot ATM per mole dot Kelvin. And then the temperature that they gave us was 22 degrees Celsius. But we have to convert that to Kelvin by adding 273 to that number, okay? And when we add the 22 plus the 273, we get 295 Kelvin. And then the volume was 5.00 liters, okay? So those are the variables that we need, or the numbers rather, that we were given to solve this, okay? Now, because we're looking for pressure, I'm going to plug all of that in, okay? Using those values here, I'm going to plug that into this formula right here. P equals N times R times T over V. So let me go ahead and pull that down here, and I'm going to use this space to plug all that in, okay? So P equals nRT over V, okay? That's the formula that we're using, and I'm going to plug the numbers in accordingly. All right, so my N is 0.350 moles times my R, 0.0821 liters dot ATM per mole dot Kelvin. times, I'm gonna have to zoom out so y'all can see the whole screen, times my temperature of 295 Kelvin, all of that over the volume, which was the 5.00 liters. Okay, so I'm gonna plug all this in, okay? And let's see what we get for our final answer. And here's the thing too, what we're going to do, we're going to cancel out our like terms. So that way we don't have to deal with those units. We're going to cancel out our moles, liters, Kelvin. You're just canceling out the units so you know what you're trying to achieve, which is your ATM. 0.350 times 0.0821 times 295 divided by 5.00 liters. And I get 1.695. Since I only need 3 of those numbers, I'm going to round that off to 1.70 ATMs. Okay, so that's the pressure for that anesthesia of that dinitrogen monoxide gas, aka laughing gas. So that was our question right here. It says, what is the pressure in ATM? And we solved it by plugging in all those numbers that they gave us to get the final answer of 1.0 ATMs. Again, this is using the gas law constant, okay? Using the ideal gas law, using the gas law constant for ATM. All right. Let's do this last problem right here, okay? And this problem here is a challenge problem. Now, why do I say it's a challenge problem? Well, because I'm going to read it out to y'all so you can see, okay, what they got right here. It says butane. All right, so they give you the formula. C4H10 is used as a fuel for barbecues and as an aerosol propellant. Meaning so that when you spray, it goes out, okay? The gas will come out as a liquid. If you have 108 milliliters of butane at 715 millimeters of mercury at 25 degrees Celsius, what is the mass in grams of butane? So again, I'm going to write here on the board, PV equals nRT. The thing is, they want to know the answer in mass. But when I say mass in grams, here's the thing. Which one of these variables here is associated with mass? It is your moles, okay? Correct. Thank you, Sammy. How you doing today? It is your moles. That is the one that's associated with grams. So you know what we're going to have to do, right? We're going to have to flip this formula to solve for your N. Since we're looking for N, here's what we're going to do. We're going to keep the P and the V together because they're all on the left side, okay? So the P and the V are kept together. And all we're going to do now is bring the R and the T to the bottom. And that's how you get your N, okay? So you're basically dividing both sides by RT, okay? Without really messing this formula up. That's what you're doing. You're dividing both sides by RT to get your N isolated by itself. Now, what we're going to do is write down, all the other components of what we have, okay? We've got P, we've got V, our R constant is according to the millimeters of mercury, and we also have the temperature, 25 degrees that we have to convert. So let me again write down all the stuff that we know. The pressure was 715 millimeters of mercury. The volume was 108 milliliters. But guess what? You've got to convert that to a liter. You're going to move your decimal back 3 places to the left, 1, 2, and 3, and you get 0.108 liters, okay? Then your R constant, if we go back up here where we were before to get our R constant, okay, it's the 62.4 liters dot millimeters of mercury per mole Kelvin. So 62.4, okay, that's our R constant right here. 62.4 millimeters of mercury dot L, moles per Kelvin. Let me make sure. Yeah, moles per Kelvin. I just wrote it differently, but it's the same thing, okay? Moles dot Kelvin. And then your temperature was 25 degrees Celsius, that you have to convert that to a Kelvin by adding 273 to that number. And when you do that, you will end up with 298, okay, Kelvin. Now, what we're going to do, okay, take care, Sammy. Good morning, Priscilla. What you're going to do is plug in those numbers, okay? Plug in those numbers. But also, let me put a little side note too. I'm going to add this. Find the molar mass for butane, C4H10. The reason why you want to do that is because you've got to convert your answer. When you get your answer in moles, you've got to convert that to a gram. Therefore, you're going to have the molar mass for C4H10. Okay, so how do you do that? In case you forgot, you've got 4 carbons times the molar mass of 12.01 from your periodic table, and you get 48.04 grams per mole, plus your 10 hydrogens times 1.008, okay? And you get 10.08 grams per mole. Again, taking care of this step up front will allow you to be less stressed when you actually get to the final end result of your problem. So the molar mass for butane is 58.12 grams per mole. You could also Google that number, but in case your teachers are giving you this on your test and they're not giving you the Google ability, all right, you're going to have to know how to find that. So let's go ahead and plug all those numbers in to our formula, okay? N equals, so the pressure was 715 millimeters of mercury times your volume, 0.108 liters. Divide that by your R constant, which was 62.4 millimeters of mercury dot liters per mole dot Kelvin, times that by your temperature of 298 Kelvin. Okay, what we need to do, of course, is to cancel out the units we do not need, okay? Cancel out the units you do not need. So I'm going to get rid of my millimeters of mercury. I'm going to get rid of my liters. I'm going to get rid of my Kelvin. And what's left, of course, are your moles right there. That's what we were solving for. So let's multiply the top numbers. 715 times 0.108. Divide that by the 2 numbers on the very bottom. And I get a very small number. So my moles here is 0.00415, because we only need 3 significant digits. Those are the moles of butane. But remember, we've got to convert that to grams, because they said, give me the answer in grams. So what you're going to do, okay, because of space, guys, I'm going to write that down here underneath it. I would have kept going right here, but I don't have space. So I'm just going to go ahead and take that number right here, okay? So I'm going to say 0.00415 moles of butane times that molar mass right here, that 58.12, that's on the top, grams of butane over 1 mole of butane. And again, cross out the units you no longer need and just simply multiply, okay? So 0.00415 times 58.12. And that gives us 3 significant digits of 0.241 grams of butane, okay? 0.214 grams of butane. Okay, that's it. That's how you do those gas law problems. So again, a lot of times you think, gosh, there's so many steps. Like, what am I supposed to do? Well, again, first you're gonna breathe in and breathe out and not panic. Okay, I don't want you to panic. No, but what I do want you to do is to, excuse me, look at the problems that you have and work with them accordingly. Thank you, Gabby. I appreciate that. So, guys, whenever it comes to problems like this, I don't want you guys to overthink. Yes, 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 yes. Thank you so much for asking and reminding me to say this. Yes, I go live Monday through Thursday, 12 noon Eastern Standard Time. And this first week, I actually went live in the evening time also on Monday, and I'll go live again this evening at 7 p.m. Eastern Standard Time. So I do go live Monday through Thursday, 12 noon Eastern Standard Time, and again tonight, 7 p.m. Eastern Standard Time. So for those of you guys that may have friends that are taking chemistry and they're not able to get on during the day, you can catch me at night. You're welcome. Ang, you're welcome. So I know that it is now my time 101. Thank you, Yas. Thank you guys so much for all the follows. I appreciate that. And make sure that when you follow, go back and, binge watch some of my videos if you're having trouble in some of your lessons. I do have this on YouTube. So I am live on YouTube. I go live on YouTube also Monday through Thursday at 12 noon. And thank you too, Star of the Hollywood. I appreciate that. Starlet Hollywood. So if you guys don't have any further questions, we're going to head on out of here, okay? But for those of you all that are prepared for your AP chemistry exams, the MCAT, if you need one-on-one tutoring, more than what I'm able to do during our lives, you can hit the link in my bio, and by all means, connect with me so that you can get the one-on-one questions that you need for your chemistry test. Okay, Wingman, you say in Chicago. You from Chi-Town? Is that what you're saying? Hey, Chavez, I ain't see us. Good to see you again. You always rock with me. Every day I see you popping up. Oh, okay. You go to the university here. Okay. What's your major? Oh, I see it now. I had to go back. You're a chemistry major, and this popped up. Well, when the universe aligns you, you got to take note of that. What year are you as? Oh, you're a junior. Okay. So you must be taking analytical or PChem and PChem. And how's it going? Are you hanging in there? Very good. Very good. Very good. PChem is, it's like a love-hate, but I actually enjoyed PChem better than I did organic. Yes. Yes, yes, yes. But I thank you guys so much for hopping on with me. I know, I did not like organic either. Okay. Yes, 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 Jocelyn, 067. I do go live for General Kim too. So I kind of have been like every other week, I give 1 week to General Kim 1, and then another week I do General Kim 2. So for a good Eklund, all right. Yes. For General Kim 2, I do go live for that. We did equilibrium constants and the ice chart a couple of weeks ago, Gibbs free energy. So I do go live for both of them, depending on what you need. Mm-hmm. Yep. Okay, you're learning this stuff, Elijah. Okay.